Welcome to another episode of the Manly Garage. We have just gotten our Mustang MD 500 dyno delivered. It was a heck of a job, and I gotta give a big thank you to Randy Goodchild and, as he puts it, the boys. Had a bunch of friends come out and help us get this thing moved in place and bolted together. Quite a job to get it installed and put in place. We ended up needing a telly, which is basically just like a tractor style forklift to get this thing in place. Just real quick, if you guys like these type of videos, make sure you click the like button and the follow button so that you can get notified. Oh yeah, you got to hit that bell thing too. But this is a Mustang Dyne MD 500 dynamometer. This has a linked belt system with multiple sets of rollers. So you've got a belt on these rollers here that links these two center ones together. You got a belt on the front two rollers that links those together. You've got common shafts between all of them. And then this belt here, which runs along this roller here. And then there's a piece of equipment that bolts in right there that allows you to couple the front to the rear. This is an older dyno, it was made in the early 2000s. You've got your flywheel here for a known quantity of mass. You've got your what's called a retarder. This is actually like a train brake. You can apply an electrical current to it and it'll apply a load to the dyno itself. And then down here, this little device right here, that's called a load cell. This guy right there. What a load cell's job to do is to measure the amount of force applied to the retarder itself. So this thing is basically just like a heavy duty scale. It's not much different than the scale that you have in your bathroom. It measures the amount of force that gets applied to this device here, which allows it to measure the amount of weight, or in this case force, to send a signal to the computer and let you know how much horsepower you're making. There are a lot of bearings associated with this thing. This thing's really dirty. It's still taken apart because I need to spray it all down and get it all cleaned up and ready to go. A lot of work yet to be done getting this thing set up. We've got to tram it up, make sure everything tracks nicely. This bearing here doesn't make some great noises, so I'm going to go ahead and replace that while I'm in there. A lot of maintenance goes into operating a dyno properly. Every single one of these bearings has a Zerk fitting on it. You can see that guy right there. They all need to be greased relatively regularly to make sure that everything rolls smoothly. You notice we roll these guys. I don't want to roll it too much because the belt is moving back and forth and I don't want to end up damaging the belt. But these guys all roll relatively quietly. You see, you move one, all of them move together. You've got all of your electrical signal lines here, sending numerous points of data back to the computer itself. You've got an inductive pickup here that measures the RPM, or the wheel speed. It monitors the teeth on this belt right here, and it picks that signal up electronically, and that's how you can get a rolling load, or rolling speed. As those teeth goes by, it's got a known calculation that it does to measure all that stuff. Another view of the retarder here. The really cool thing about this whole setup is that it only needs one 220 volt 50 amp circuit to work, and then it comes with, you're gonna have to forgive the mess, we had to move quite a bit around to make sure that we were able to get everything in here. This guy here, this is the entirety of the power box associated with the dynamometer. Here's the, it's the other direction. Gotta get these guys loose. Anyways, inside here is the circuit that you need to run this thing. That is the entirety of the power. And then it's got a single 220 plug. So I got to get power run to get this thing up and operational. I got a couple blowers already. We're going to be getting some more here in the near future. We got our anchors and all of our hardware in this box right here. A lot of work still yet to be done. This dyno did not get used a whole heck of a lot at the previous shop with the previous owner. So it's got very low miles on it, which is cool. But there's just little things like this. This bolt here has ended up needing to be drilled out so we can get one of the panels off. So we've got to repair that. All of the air lines worked, everything, the air brakes, all of that stuff's in good condition. Really excited about it. It's going to be a lot of fun to figure out exactly how we're going to ventilate the shop, figure out how we're going to ensure that we get the exhaust gases out properly. I want to talk a little bit about how a dynamometer works and how it measures power and correction factors and things along those lines. This space here is actually the calibration point for ensuring that that load cell measures the correct amount of weight and static weight for your dyno. And if that measurement itself is not accurate, you end up getting false readings. So every single time I run this thing, there's a panel that goes on here. I end up lifting that panel, and then there's a 40-pound weight that ends up, you set it right here. It's just a big block of metal, and you set it there and you tell the dyno to calibrate. Now, if you are not doing that regularly, as the dyno temperature changes within the room, if you're not in a pure, like absolutely purely climate controlled room, the dyno itself will heat up, will cool down, and as the metal physically changes and flexes, it will apply a different load here. So similarly to like zeroing out a scale or something along those lines, it is exactly the same procedure. You end up setting that weight there. The dyno measures the exact weight of what's going on there, and it will basically zero it, and it'll know that, hey, this is what 40 pounds looks like today. So ensuring that you get that thing measured up every single day is absolutely critical. And like realistically, if you start the day and it's 70 degrees Fahrenheit in the shop, and then it goes to, let's say, 105, which is not uncommon in Northern California, you can end up getting the metal itself expanding, and that base measurement value will end up changing. So making sure that that is set properly is kind of step one. And then step two is ensuring that the sensors on the computer itself are measuring accurate values. If you end up measuring an incorrect air temperature, and that is adjustable there, you can get a false weather station value, or it has been known that some shops will end up putting that kind of by the heater and telling the computer itself that's measuring the horsepower that it is warmer than it actually is, which will induce an incorrect correction factor, and it will basically tell the computer that it needs to increase the amount of power via calculation for a known ambient temperature. So SAE correction factors are all based off of a standard temperature and pressure. And when the ambient conditions deviate from that standard temperature and pressure, there is a correction factor that is applied. Now, that correction factor is primarily utilized for naturally aspirated engines. When you're turbocharged, if your turbo is appropriately sized, that correction factor doesn't necessarily apply because you are introducing an artificial atmosphere to the intake manifold of the engine via boost. Everybody loves boost, right? Yeah, everyone loves boost. So you can get artificially inflated numbers a number of different ways. The big one is via an incorrect atmosphere reading via the sensors on the computer itself. Anyways, we're getting close to getting this thing wrapped up. Still have to finish up the engine swap in the SQ7, get that all situated. I've got to get all of this cleaned up. We're looking at a minimum, cleaning this thing off and potentially painting it this weekend, this upcoming Sunday, getting everything set up in that department. We've got all of these panels that need to be installed. We've got a bearing that needs to be replaced. I cannot tell you how much work this damn thing is. I mean, every bolt is massive. Everything is heavy. Moving anything a fraction of an inch here or there is a ton of work. And I get it, and I got to give a big shout out and thank you to Randy for recommending that I purchase this thing. This is called a Johnson bar. And with this bar alone, a man can slide this under. I don't have enough room to work it right here, but you can lift up to 11,000 pounds. You see, I'm actually slightly lifting that dyno there, and I did that with one hand. If you need a Johnson bar, I'll include a link in the video description below about where you can pick that up. Man, this thing is in need of some love, but I'm excited that it's here. I want to give a big thank you to Paul at FW Motor for making himself available so that we could come pick this up out of his shop. And a big thank you to Max DeBecker, also of FW. And those guys are located in Rockland, California. If you need your Subaru serviced in the Northern California area, they do pretty much everything. They're absolutely passionate, and they love those cars. So wanted to make sure I gave them a shout out. They're the guys who ended up selling me the dyno, and were kind enough to store it until we had the shop space situated to accept it. So big thank you to those guys for making themselves available. We're going to start putting this thing together, and once it's up and operational, we're going to start making some power. It's going to be really exciting. Got to get the anchors installed in the ground for our strap down points. Got our 3D printers in here for prototyping parts in the very near future. Excited about that. We've got our 3D scanners going. We've got everything rocking and rolling to really get this R&D facility up and operational and producing some really unique, high quality products. We've got some really cool industry partners that we're working with. Big shout out to Gorder Racing in the Netherlands and Kayvon Kashe here in the Sacramento area. He's an absolutely phenomenal fabricator. He's been helping us design the turbo kit for the EA 824 engine that we're going to be bringing to market once we've got all of the rest of the shop situated. But he helped build these wonderful downpipes that we integrated the OEM catalytic converters with for use with these bad boys right here on this motor right here. But yeah, it's coming together. I ended up having to pull the motor back out of the SQ7. When going together, there was a binding issue between the torque converter and the flex plate that I got to get solved and get that situated and up and operational. But it's all coming together. We're getting there one day at a time. Hell of a lot of manual labor, but we're almost done. If you guys have any questions about dyno operations, if you guys have any thoughts on other videos that we could produce that you guys would enjoy, please do not hesitate to let us know in the comments. We will be producing a lot of content for this channel utilizing this dyno. For those of you that don't know, I've had the Manly Garage running for quite some time now. It was a personal page, and I have since started a company called Leistune. We develop high quality OEM style calibrations that deliver an increased amount of power while ensuring that all of your OEM emissions equipment remains intact and operational. I think the future of performance is going to be emissions compliant performance. I've got 3 kids personally, and in my younger years, I was like, hey man, I really don't understand why, we've got all these emissions controls thing, limiting power. But as I've gotten older, I realized, like, man, there really is a huge benefit to ensuring that we keep the environment and our air clean. As I remember as a kid in the 80s, going to visit my family in Southern California, and you'd get down there and the smog would physically hurt your lungs after 24 hours worth of exposure, and they would ache for 3 or 4 days. So that's primarily what inspired me to get all of this stuff up and operational. I want to deliver OEM style, emissions compliant calibrations where we don't end up changing any of the areas of the calibration that is going to affect the amount of pollutants that ends up getting produced. We just increase power on the top end and make sure that it's running at the appropriate air fuel ratios so it doesn't end up burning up your catalytic converters, making sure that everything is done safely with appropriate monitoring, conducting R&D on our own personal shop vehicles if we're going to end up pushing the boundaries of what's possible with these calibrations. We push this thing to 800 wheel horsepower and 900 foot-pounds of torque on this dyno right here while it was still located at FW. And it made an absolutely absurd amount of power. And unfortunately, we ended up breaking a motor, but I knew going into it that we were going to be pushing the outer limits and that was a possibility. So we did it. We've developed a solution that we will be bringing to market that will allow us to run that power level safely, again, without sacrificing the emissions components. So if you guys have any questions about the future of this channel, the future of the Manly Garage, the future of Leistune, content that you'd like to see, make sure you drop a comment below. We love hearing back from you guys and answering your questions. But yeah, I think that'll wrap it up for today. You guys have a wonderful day. It is Tuesday, almost the weekend in my mind. I've got a lot of work to do, a lot of calibrations to write, a lot of products to deliver today. I just wanted to thank our clients for being patient with us. We did end up having a little bit of a family emergency that we've had to address for the past few weeks, but we are getting back up to full speed. We have shipped everything now that has been ordered. Our goal is to be the Amazon of calibrations. You order it, it ships within 24 to 48 hours, and we get it to you as quickly as possible. If you guys have any questions, drop them in the comments. Thank you very much. Have a great day.